you need to mathematical operation on sequence. So I ask what is convolution to Sonam Togge. So Sonam Togge is not answering. So I'm passing this question to Pema Chora.
Yes, sir. A convolution is when two signal combined together, sir.
Okay.
Mixed together, sir.
So convolution is the process where you are going to mix two signal. One signal will be cut down, input signal, and other will be impulse response. Then you will get output y of n. And convolution is given by y of n is equal to x of n convolution sin g star star vemos star leshaimidi, then h of n, which is impulse response. So in this unit, we are going to look into convolution, linear convolution, where we will look into graphical method, and we will look into two type, overlap and add method and sliding type method. And we will look into analytical technique and matrix method, matrix 1 and 2. And these are the things that we are going to learn, and we are going to solve some examples. And this should be learned in MATLAB example. But you said you are going to use Python, PyCharm, Lapchimush. You want
Yes,
to
sir.
MATLAB or Python, PyCharm? Gaji speni. Na khasan discuss maybe Lapchiba.
MATLAB.
Please tell me which you want to use for our
Maybe
MATLAB.
ina. Tobe MATLAB imbachi MATLAB berashage. Okay, signal manipulation. So I have copied directly from textbook, which I share with you. Textbook na Jimena ebook the anale. Signal manipulation in our study of discrete time signal and system. We will be concerned with manipulation of signal. These manipulations are generally composition of few basic signal transformation. This transformation may be classified either as those that are transformation of independent variable in, or those that are transformation of amplitude of x of n, that is dependent variable. In the following two subsections, we will look briefly at these two classes of transformation. Two classes of transformations are the independent variable n and dependent variable x of n. And those that are most commonly found in application. So transformation of independent variable, that is n. Sequences are often altered and manipulated by modifying the index n as follows. So y of n is equal to x of f of n, where your f of n is some function of n. If for some function, some value of n, f of n is not an integer, y of n is equal to x of f of n is undefined. Now determining the effect of modifying the index n may always be accomplished using a simple tabular approach of listing for each value of n and the value of f of n, and then setting y of n is equal to x of f of n. However, for many index transformation, this is not necessary, and the sequence may be determined or plotted directly. The common transformation include shifting, reversal, scaling, which are defined below. The reason why we are studying this signal manipulation is we are preparing for the signal convolution. Directly we have to go to signal linear convolution, but before that we need to know how to do the shifting, time shifting, reversal, time scaling, and so we are going to look this one. So what is shifting? This is the transformation defined by f of n is equal to n minus n naught. if y of n is equal to x of n minus n naught, then x of n is shifted to the right by n naught, and n naught please null. By n naught sample if n naught is positive. Ana JSON please. Ana n naught nichara n naught is positive. Dachi yani explain be. So it is shifted to left by n naught sample if n naught is negative. Ana no zemedi n naught into ga. Now reversal. The transformation is given by f of n equal to minus n. Simply involves just flipping the signal x of n with respect to index n. Now time scaling. So the transformation is defined by f of n equal to m of n or f of n, which is equal to n divided by n, where m and n are positive integer. Now in case of f of n equal to m of n, the sequence x of m of n is formed by taking every mth sample of x of n. This operation is known as downsampling, which means if you have a scaling that is m positive a watching, that means your signal will be shrink, signal chungujong. But if your time scaling is smaller, which means 1 by n, 1 by n n is a positive integer. The sequence y of n x of f of n is x of n is defined as follow. And here is the example how signal are shifted. And this one is signal shifting. This one is original signal. So you are giving x of n minus 2. So the signal is shifted towards right side. And this one is time reversal. So you are just flipping the signal, and this will reach at minus 5 now. And this one will reach to minus 1. And this one is time scaling, where your scaling is positive integer, which is greater than 1. Greater than 1 in bachin, your signal will get shrink. Signal chungujong, ana chungujong emotion. And this one is signal when your scaling factor is less than 1. That is half to what, 1 by 2. Then signal get bigger. Scale change. So this is what you have studied in signal and system na. I'm not going detail. Now you have addition, multiplication, and scaling. Addition, multiplication, and scaling. The most common type of amplitude transformation are addition, multiplication, and scaling. Performing this operation is straightforward and involve only point-wise operation on a scale. Now addition, the sum of two signals is given by y of n. So you have two signals, x1 of n plus x2 of n, where n range from minus infinity to positive infinity, and is formed by point-wise addition of the signal-wise. So in order to add the signal x1 of n and x2 of n, you should add, for example, at signal x1 of n now, at point 0 na, at origin 0 na, if you have true, that signal is 2, and if you have x2 of n na, 1 2 plus 1 equal to signal 3, then your y of n will equal to 3 mush. So you know this one. This is again the revision of signal and system now. And you have a multiplication. The multiplication of this signal is given by y of n equal to x1 of n times x2 of n, where n range from minus infinity to positive infinity. Is formed, again, it is formed by point-wise product of the signal value. Now scaling na ibachin, the amplitude scaling of signal x of n by the constant c is accomplished by multiplying every signal by constant c. Now in order to scale your signal, you should multiply the signal by this constant C at every point. 0, 1, to get nalu, you should multiply in order to get your new signal y of n. This operation may be considered to be product of two signal x of n and f of n, which is we consider C as f of n. Hagoiga. So first lab will be signal addition, multiplication, and scaling. Your first lab work will be any shifting shifting, reversal, time scaling, addition, multiplication, and scaling. 6 things. So I want you to do this one in MATLAB, where you should change the x-axis key and clar change pe y-axis na ming dini tele level gajebi na ani suge detail na change pe go tuba. So I'm going to prepare the question for lab 1 and I will upload in VLA. Hagoiga.
Bueno, sir.
On baby jonu sachisu. Gagia len milabe.
Majuna, sir. Yela, sir.
Allah, yellow, sir.
Jonu was the same way.
Hello, sir. Hello.
Sir, any MATLAB download when you link to
Why? Ani bin mellab di ane gomno ji ebachi su gobachin.
I download the visual, sir.
Medo
Big formula.
ane mellab di ane achi deme. Okay, finally now we are entering to our main topic. Linear convolution of discrete signal. The relationship between input to linear time shift invariant system x of n and output y of n is given by the convolution sum. So this is the convolution imbate. X of n convolute h of n. So this is nothing but y of n imbate mosh, which is given by summation k range from minus infinity to infinity x of k h of n minus k. Chi duga chi ane baby.
Dula, sir.
Hello.
So this one is definition of convolution. So you can write instead of this one y of n z tuba. First y of n is equal to anitigo. Then finally y of n equal to anitigo. So this is definition of convolution.
Yes, sir.
Convolution properties. Convolution is a linear operator and therefore has a number of important properties including commutative, associative, and distributive properties. The definition and interpretation of this property are summarized below. First, commutative property. Commutative property states that order in which two sequences are convolved is not important. Mathematically, the commutative property is x of n convolute h of n is equal to h of n convolute x of n, which means you can interchange the position of that operator h of n and that impulse response. So this is known as commutative property. From the system point of view, this property states that system with unit sample response h of n and input x of n behave in exactly the same way as the system with unit sample response x of n and unit impulse and input h of n. So when you interchange, this become input, this become impulse. So which means that convolution property states that either way it can be, it can happen. This input can become impulse response and h of n, that impulse response, can become input. So this is what commutative law state. And the rest associative law and distributive law is again homework. And in homework la misu you should write tuga. Chi ani china deve ani su tabe digoba. Exam na home. Ngagidi ani ati so seba. Chigi that sense exam same na bebo. If we happen to carry out online exam na bewaching question, each question will have certain minutes ime. And chikabe mijin na question. And bendigi you should study from beginning itself. So here is the block diagram, interpretation of convolution property from the system point of view. First one is commutative law. As I said, we can interchange this h of n anatomy. Just now your x of n is an input and h of n is an impulse. So as per the commutative property, they can interchange. Here x of n become impulse and h of n become input. And I have associative property here, a distributive property. But this equation you should write as a homework. Anyway, let's see what is associative property. Associative property na bewachin, you will have two impulse response, h1 of n and h2 of n. So these two impulses can be mixed together, and this block, this first system and this system are equal. So this is what is known as associative property. And regarding distributive property, you have two impulse response which is in the parallel way. Parallel. So if your two impulse response are in parallel, you can add together. So this is equal to this one. So this is what is known as distributive property. If your impulse response are in serial, you will do multiplication, that is convolution. If they are in parallel, so you will do addition. If you do multiplication, that is convolution, that is associative property. If you do addition, that is known as distributive property. For detail, you are going to write associative property and distribution property as a homework. How going?
Law.
Another homework, other two properties of convolution, associative property and distribution property. Now you are going to look into graphical method, overlap and add method, and sliding type method. End of lecture. Time comes to
1 or 2
1 hour.
we will take rest.
Or 2
Devi anara de khala bedegi tuga.